Hello, a very good morning to everyone present here with the warm greetings. It's given me a great pleasure to extend a warm welcome on behalf of the Department of Civil and Mechanical Engineering, conducting one-day webinar on Advanced Industrial Wastewater Techniques. Here, I like to express my profound gratitude to our chairman, Mr. MSN Murthy, correspondent and president, Mr. Sivaram Prasad Garu, and I would like to express my profound gratitude to our principal, Dr. P. Venkateshwara Garu, and Vice Principal, Dr. Balaji Garu, and all the faculty members of VSM COE for their blessings and guidance and motivation. I would like to give few introduction about our college. VSM College of Engineering, established in the year 2009 by Ramachandrapuram Educational Society, is one of the premier institutions affiliated to JNTU Kakinada, keeping in the view that vast changes in the requirements of the society and nation at the large due to fast delivery in the industrial and service sector. And a recent focus of technical education has been innovations, research, and development, along with the major changes in curriculum. And strategies of teaching, the institution was established in spite of all the stiff competition at all levels due to globalization. And the output in the form of gratitude is required to match with the global expectations. However, this institution is trying to cope up with the change and is trying its level best to strategic steps for improvement. The institution aims to be a leader in technical education and as well as the management education in the area of East Godavari district. And a state has a whole to any unique identity for the development of high quality knowledge and diversification of teaching, engineering, and management education. Next, I would like to invite our resource person, Mr. Leela Arvind. He is a senior technical engineer and a design engineer from SDVL Consultancy, Kakinada. I also welcome our beloved HOD, Department of Civil Engineering and Mechanical Engineering, for his continuous support. Otherwise not possible to conduct a webinar like this. We welcome you, sir. And I also welcome for the today's session all the seminar students who are registered. And I welcome all the students for the students webinar. And thank you for registration. And also welcome all the colleagues of the today's session. Thank you, sir. Arvind, sir, please carry on.
Hello. First of all, my name is. I'm explaining about in this topic is advanced wastewater management techniques. First of all, nowadays wastewater management is very required. example, there is water management is very required for several purposes. First of all, what is a resource? A resource common activities what to use it in the day-to-day life. Uh, Water is used in the several purposes like expenses, drinking purpose. So much consumption of water is used in our daily life. So water is the basic requirement to any person in our day-to-day life. So much water is consumption in our daily life means so much wastewater are we consumed in life. And there was a lot of the water can be made in the some place and some path. So we are using wastewater management system. For example, if you consider like paper mills and it was using water in our day-to-day life. Okay, and
తమ్ముడు
some disturbances are causing, so that's why. So in our day-to-day life, wastewater management is very required. And wastewater management are we consumed in the drainage expenses, drainage household expenses, and drainage systems are in India are most adequate in nature. And some of the drainage systems are not much unique, and there were collapse due to some causes. So when we are using any industries, there were consuming large amount of wastewater in the in their life. So some of the techniques are used in the wastewater management techniques in the advanced level used to remove that wastewater in that manner. So industrial wastewater management describes the process used for treating wastewater management that is produced by industries, and it is undescribed by the product and undesirable product after treatment. The treated wastewater and the wastewater may be reused or to release it as sanitary or surface water treatment in the environment. Most industries produce some wastewater. So recent times trends have been much minimized for the production or to recycle treated wastewater within the production process. So sources of industrial wastewater management has been wastewater include battery manufacturing, electric power plants, food factory, iron and steel, mines and quarries, nuclear industry, oil and gas extraction, organic chemicals, manufacturing, petroleum refining, and petrochemicals, pulp and paper industries, textile mills, industrial oil contamination, water treatment, wood preserving, treatment, treatment processes include brine treatment, solids removal, example, chemical precipitation or filtration, oil and greases. Oil and greases are the removal of wastewater management, another organic removal, and alkalis removal of alkalis materials. So what are the sources of wastewater management? So basically the sources are like industries and exports and imports of the some factories, and there were lots of construction of the wastewater management. So what are the main things that we are consuming in the wastewater management is, so wastewater management treatment means battery manufacturing. First of all, first one is battery manufacturing. Okay, what is the battery manufacturing means in our day-to-day life, batteries are the using in our day-to-day is very much uh, when you are in the inverters and some household in any purpose that and we are doing the ponds like there was very lot of construction of the batteries very much adequate, and they were most useful. Okay, so battery manufacturing is the most cause of the wastewater management technique. So they were polluting some water. So what was the kind to do in the battery manufacturing is, battery manufacturing specializes in fabricating small devices for electronics and portable equipment. Example, power tools or larger high powered units for cars. So, and trucks and other motorized vehicles using pollutants in our automobile gases, and there were the motorized vehicles pollutant generated or manufacturing plants includes cadmium, chromium, cobalt, copper, cyanide, iron, and lead, manganese, mercury, nickel, oil and grease, silver and zinc. So these were the main causes for the battery manufacturing. So next one is electrical power plants. So electrical power plants means in our day-to-day life, electricity is very much consumption in our day-to-day life. Without electricity, there were no use, there were no life in any with any people. So electrical power manufacturing power plants is what the basic one of the wastewater management is, that they releases fossil fuel power plants, particularly coal pile plants are a major source of wastewater management. Many of these plants discharge wastewater with significant levels of metals such as lead, mercury, cadmium, chromium, as well as arsenic, selenium, and nitrogen gases, compounds, nitrates, and nitrites. Wastewater management consumes in the fuel gas, cadmium, and fly ash, bottom ash, and the fuel gas, the mercury and wet scrubbers, and typically transfer the captured pollutants to the wastewater stream. So, for example, if you consider the ash ponds in a surface in compoundment are a widely used treatment technology are to a coal-fired plants. These ponds use gravity to settle. 1 minute.
Hello, measurement.
Okay, కొంచెం వేసుకోవడా ట్రీట్మెంట్ కావడం లేదా Hello guys, the basic net problem is interruption for the cause of maybe. Okay, so this is the advanced wastewater treatment methods complete list. So if you consider the, so what is wastewater treatment? Wastewater treatment is that, 1 minute. Sewage or wastewater is a dilute mixture of various waste from residential, commercial, and industrial areas. This wastewater is treated to reduce its objectionable properties, so that can cause unfavorable changes to environment and man. Okay, the conventional wastewater treatment methods are used to reduce the amount of suspended or floatable materials and treatment of biodegradable organic matter present in it. But advanced wastewater treatment methods are mainly used to remove all nutrients, suspendable solids, dissolved solids, and toxic substances present in it. Suitable waste treatment method is adapted on the basis of the environment present in the contaminant present in the wastewater. Okay, types of advanced wastewater treatment methods for suspended solids. First one is microscreening. Second one is ultrafiltration. Third one is chemical coagulation and clarification. For organic matter, first one is absorption using activated carbon. Second one is biological oxidation. Okay, for the removal of phosphorus, chemical precipitation and clarification, and chemical coagulation and clarification. So all the methods are briefly explained as below. Okay, wastewater treatment by microscreening. Microscreening method when we use it and to treat the wastewater treatment. Okay, the equipment used for the microscreening process is a rotating drum either with a plastic filter fabric or woven metallic mesh having an opening size of 20 to 60 mic attached on its periphery. The drum is fitted inside the wastewater flow channel and it continuously rotates at a speed of 4 rpm. The wastewater enters into the horizontal drum at its upstream and rotates radially outward through our mesh or microfabric and leaving behind the suspended solid material which has a diameter greater than the diameter of mesh. So this is the image. So this is the image of the microscreening using wastewater treatment. So in this microscreening, and we used wastewater treatment. Okay. So the deterrent solids in the machine inside the drum are backwashed using a high pressure water jet and recycled into the sedimentation tank. When the screening process proceeds, the ports get clogged by the accumulation of particles and this causes the development of a pressure inside the drum. So this pressure will further help to the filter small suspended particles which have diameter less than mesh opening. So wastewater treatment by ultrafiltration. Okay, in our home, we are using the for purification of water when we are using the water purifiers. So that water purifiers, some purifiers containing RO plus UV and some purifiers containing RO plus UV plus TDS. So what it means? It means the purification level states from one high state to the further high state. So it is a bundle of thin, for suppose if you consider the wastewater treatment ultrafiltration, so this is the bundle of thin membranes of organic polymer of about 0.005 to 0.1 inches thick that are casted together to act as a single to pulp filtration. It has extremely thin separation layers with a pore size of 3 to 100 angstrom degrees. This technique is widely used in the conjunction with the activated stretch process, and the effluent passes through the ultrafiltration tube. The membrane thus retains in it. Returning okay, next one is treatment of a chemical coagulation clarification. So in this method, if you are using the chemical coagulation, is the process of adding a chemical which can destabilize the colloidal and suspended particles in the wastewater. As a result of destabilization, the size of the particles will increase and they settle as a flock due to the flocculation and agglomeration. These settled flocks can be removed using a sedimentation tank, and the superintendent will be the treated effluent. Typical coagulants used are natural and synthetic organic polymers, metal salts such as alum, ferric sulfate, etc. So this is the basic image of the chemical coagulation for clarification. So okay, this is the clarifier basics of the wastewater management technique, and this is the MLSS from aeration basin. Okay, and this is the recycle or waste RASWS underflow, and this is the water flow where effluent. Okay. So next one is absorption using activated carbon. Okay, char is produced when organic materials are heated at a temperature of 700 degrees centigrade. Okay, this char is activated by exposing them to oxidizing gases such as steam and CO2 at high temperatures. These gases develop a porous structure on the surface of char, which in turn will be activated carbon. This can be used to absorb the organic materials into its surface. The absorbing sites can be regenerated when it is saturated. So this is the water purifiers basically using the carbon in the activated carbon. So this image when you are actually seeing in most of the areas. So next one is chemical precipitation. Phosphorus is present in wastewater generally in the form of organic phosphate, polysulfate or orthosulfate. This reaction consisting of adding chemicals all of ferric chloride into the wastewater and they coagulated the phosphorus present in it. The coagulated material will precipitate such as aluminum ferric, and this can be clarified as further. So this is the image of wastewater treatment by chemical precipitation. Wait. This is the image. I'm on the outside course due to some technical issues. The net was not interrupting, and so many problems facing while doing the computer management. Yes, and this is the water management. Okay, so this is my presentation on the water management. Water management. Okay, okay. Sewage treatment and domestic wastewater treatment. Okay, the process of removing contaminants from wastewater and household sewage. So before I will telling the wastewater management and household sewage. So in our day-to-day life, we are using large consumption of wastewater from household expenses and industrials and so many purposes. So both runoff effluents and domestic. Okay, and process of producing an environmentally safe fluid waste stream or treated effluent and a solid waste or treated such shortfall for disposal are used usually as form fertilizer. So and next one is sewage treatment involves three stages, and there are first one is primary treatment, second one is secondary treatment, third one is tertiary treatment. So before sewage treatment means sewage treatment when you are means from dust. Okay, first one is pre-treatment. Okay, it removes materials that can be easily collected from the raw wastewater. The waste may damage or clog the pumps and skimmers. A primary treatment clarifies straws, tree limbs, leaves, etc. Second one is screening. Okay, sewage wastewater is screened to remove all large objects carried in the sewage stream. And next one is grit removal. Grit means dust or any other particles in the wastewater. So that we are removing in that purpose means grit channel or chamber where the velocity of the incoming wastewater is adjusted to allow the settlement of sand, grit, stones, and broken glass. So water flow is not constant. The water is transferred from the high velocity to the low velocity with the running velocity with the speed of maximum temperature at any surface. Okay, so the water from the higher velocity to lower velocity. So due to the form of some sand, grit, stones, and broken glasses. Okay, these are the main things. And next one is grit removal is desirable for larger plants. Okay, grit channel or chamber where the velocity of the incoming wastewater is adjusted to the allow the settlement of sand, grit, stones, and broken glass. Grit removal is desirable for larger plants. Okay, next one is pattern grease removal. Pattern grease is removed by passing the sewage through a small tank where skimmers collect the fat flowing on the surface. Air blowers in the base of the tank may also be used to help the recover the data effort. And next one is the primary treatment. Sewage flows through larger tanks, commonly called primary clarifiers or primary sedimentation tanks. Grease and oils and the coating material can sometimes be recovered for saponification. Sedimentation tank may remove from tissue percent suspended solids and from 30 to 35% of the biochemical oxygen demand BOD from the sewage. Okay, next one is secondary treatment. To sustainably degrade the biological content of the sewage, which are derived from the human waste, food waste, soap and detergent. The majority of municipal plants treat the settled sewage liquor using aerobic biological process. The bacteria and protozoa consume biodegradable soluble organic contaminants and bind much of the less of the solution franks into frog. Okay, next one include trickling filters and rotating biological contractors. Trickling filters which trickle the water and they remove the dust, sand, and any other contaminating bacteria from the water sewage treatment. So and this is the trickling filters were used. So before we are knowing the trickling filters, okay, it's a main topic in the environmental engineering topic. Okay, and next one is secondary treatment. Fixed film or attached growth systems include trickling filters and rotating biological contractors. Okay, suspended growth systems include activated sludge where the biomass is mixed with the sewage and can be operated in a smaller space than fixed film systems and treat the same amount of water. Next one is roughing filters to treat particularly stronger roughing filters to treat particularly strong or variable organic loads, typically industrial, to allow them to then be treated by conventional secondary treatment process. It is pushed through the media using blowers. The resultant wastewater is usually within the normal range for conventional treatment process. Okay. Next one is surface aerated basins. The surface flowing with the underground water maybe contains some bacteria and other excavated particles before we are using the wastewater contamination of the tanks. Okay, aerators provided two functions. Okay, they transfer the air into the basins required by the biological oxidation reactions. They provide the mixing required for dispersing the iron and for contact the reactants, achieving 80 to 90% removal of a BOD with retention times of 1 to 10 days. Surface aerated vessels operate at between 4 degrees and 30 degrees centigrade. Okay, filter beds. Filter beds which filter the sewage, liquor, and is under the surface of a bed is made up of coke. Naturally propagated plastic media must have larger space areas to support the biofilm that form. Biological films of bacteria, protozoa, and fungi form on the media surfaces and eat or otherwise reduce the organic content. Biological aerated filter. Okay, next one is biofilters combine filtration with biological carbon reduction, nitrification, and gentrification. Include a reactor filled with a filter media. The dual purpose of this media is to support highly activated biomass that is attached and to it and filter is suspended to the solids. Carbon reduction and ammonia conversion occurs in aerobic mode, while nitrate conversion occurs in anaerobic mode. Okay. Next one is rotating biological contractor and rotating. Okay, robust and capable and withstanding surges in organic load. The rodents support the growth of bacteria and microorganisms present in the seawater. Oxygen is obtained from the atmosphere as the discs rotate. Effluent from the RBC is then passed through the fine clarifiers where the microorganisms in suspension settle as sludge. Okay, next one is secondary sedimentation. The final step in the secondary sedimentation stage is settle out the biological floc or filter material through a secondary clarifier to produce sewage water containing organic material and suspended matter. And next one is tertiary treatment. This is the sewage treatment process, and this treatment we all know that is that the main purpose is that is to provide a final treatment stage or to raise the effluent quality before it is discharged to the receiving environment. It is also called the effluent polishing.
Okay, sorry for the interruption all. So I'm feeling honored to get this great opportunity to express gratitude to everyone involved in this successful organization for this webinar. Today, all get the opportunity to know about the importance of reuse of industrial wastewater by the webinar entitled Advanced Industrial Wastewater Techniques. Now, this is a time to convey gratitude towards everyone. First, I like to express my profound gratitude to our correspondent and president, Mr. Sivaram Prasad Garu, our beloved chairman, Mr. MSN Murthy Garu, and Dr. Garu, and all for their blessings and guidance and motivation. I feel privileged to express my deep gratitude to our guest, Mr. Leela Arvind sir, for their knowledgeful guidance as well as the precious time. It is a time to thankful to Mr. Sri Kalyan, okay, and teachers for this fruitful organization and technical support. And also I'm thankful to all the participants for their registration in the webinar. And I hope such huge support continue with our next webinar. Okay, eventually we send a feedback link. So please fill the feedback link. Stay home, stay safe. Enjoy the time of learning. Thank you. Thank you very much.
Hello.
మీరు అలా కట్ చేస్తున్న 5 minutes అలా కనిపిస్తున్నాను.
Hello, good morning everyone. Hello. Hello.
Sir. Want to ask Mr. Lee.
Hello, Srinivas sir. Hello.
Good morning, everyone.
Sir, can you?
I'm Srinivas Ontedu, 2020 pass out mechanical student. I want to share my words with you, if you all agree.
Yeah, carry on. Go ahead.
Okay. Okay. First of all, water అంటే ఏంటంటే లిక్విడ్ వాటర్ అనేది అందరికి మనకు తెలిసిందే, ఎప్పుడు యూజ్ లో ఉండేది లిక్విడ్ మినరల్ లో. ఇది మనకు వేస్ట్ గా ప్రతి దిక్కున మనకు అవసరమైన మెటీరియల్ ప్రతి దాంట్లో వాడాల్సి వస్తుంది. ఇది ఒక లిక్విడ్ మినరల్ లో. వాటర్ వచ్చేసి బేసికల్ గా 2 టైప్స్, హార్డ్ వాటర్ అండ్ సాఫ్ట్ వాటర్. హార్డ్ వాటర్ అనేది మాక్సిమం ఎక్కడ యూటిలైజేషన్ లో ఉండదు, మాక్సిమం వాడలేము. సాఫ్ట్ వాటర్ వచ్చేటప్పటికి మనం ఏ విధంగా వాడాలన్నా దేనికి వాడాలన్నా సాఫ్ట్ వాటర్ నే మనం ప్రైమర్ గా తీసుకుని వాడతాం అనమాట. ఈ సాఫ్ట్ వాటర్ మనం బేసికల్ గా డ్రింకింగ్ కి, ఫార్మింగ్ కి, ఇండస్ట్రీస్ కి, దీనికి మాక్సిమం